Ready, ma'am?
Okay, sir. Good morning, one and all.
Madam, start.
Good morning, one and all. Myself, Swapna, JL in Chemistry from Vangara. Today, we are going to discuss the new chapter, that is D and F block elements and coordination compounds. This is belongs to second year and chapter 7. D and F block elements. What are the D and F block elements? First of all, based on entry of differentiating electrons into various orbitals, the elements are classified into 4 blocks. We know that they are S block elements and P block elements, D block elements and F block elements. S block elements. These are first A group elements and also called alkali metals, and second A group elements. These are also called alkaline earth metals. These S block elements are already you studied in first year. P block elements. These are 13th group elements, 14th group elements, and 15th group, and 16th group, 17th and 18th group elements. 13th group elements. This is also called boron family. And 14th group elements. These are also called carbon family. This 13th group and 14th group also you studied in first year. 15th group elements, 15th and 16th group elements, 17th group and 18th group elements. Just yesterday you completed 18th group elements. Now we will going to discuss the D and F block elements. D block elements. What are the D block elements? Yes. The elements in which the differentiating electron enters into D subshell or D orbitals are called D block elements. D block means the elements in which the differentiating electron enters into D subshell or D orbitals are called D block elements. These are placed in between the S and P block elements. These are D block elements. These are placed in between. These are S block elements and these are P block elements. These D block elements are placed in between S and P block elements. These are D block elements. Occupies the more space in our periodic table. General electronic configuration of D block elements. This general electronic configuration is N-1 D into 1 to 10 and NS 1 to 2, where N is equal to 4, 5, 6 or 7. Here the N-1, the N-1 is stands for penultimate shell. Here D orbitals which may have 1 to 10 electrons and outermost NS orbital may have 1 or 2 electrons. In this here the D orbital, this is a D orbital. This D orbital which may have 1 to 10 electrons, and this is an outermost NS orbital. This outermost NS orbital may have 1 or 2 electrons. Then it has 10 groups. They are from here 3 to 12th groups. Okay, it has 10 groups. They are 3 to 12 groups. These are arranged in 4 series. Those are first transition series and second transition series and third transition series and fourth transition series. First transition series is 3D series. Okay, first transition series is 3D series. It is also fourth period. The 3D series is also fourth period. Here the 3D series is starting from the scandium and ends with the zinc. Okay, here the 3D series is started from the scandium and ends with zinc. Okay, here the scandium atomic number is 21 and zinc atomic number is 30. Here and next to 4D series. The 4D series is fifth period. Okay, the 4D series is fifth period. It is started from yttrium and ends with cadmium. Here yttrium atomic number is 39 and cadmium atomic number is 48. Next goes to 5D series. Here it is an 5D series. It is belongs to 6th period. Okay, 5D series. It is also 6th period. It is started from lanthanum, and after this lanthanum, elements are belongs to F block elements. Okay, then here the lanthanum and hafnium, and ends with the mercury. The between the lanthanum and hafnium, the elements are belongs to F block. Okay, those are not belongs to D block elements. Here the lanthanum is belongs to D blocks. Here it is started from lanthanum and end with the mercury. Here the lanthanum atomic number is 57 and mercury is 80. And next series is 6D series. 6D series is belongs to 7th period. Okay, 6D series is belongs to 7th period. Here it is started with the actinium and its atomic number is 89. It is the incomplete period. Okay, it is the incomplete period or incomplete series. Here the each series, those are 3D series, 4D series, 5D series and 6D series. Each series contains 10 elements. You count now. Here 1, 2, 3, 4, 5, 6, 7, 8, 9. So here each series contains 10 elements because of the d orbital. The d orbital is accommodating a maximum of how many electrons? 10 electrons. That is the reason here each series has 10 elements. Okay, these are d block elements. The d block elements are arranged in 4 series. Those are first transition series, that is the 3D series, and fourth period started from scandium and ends with zinc. Its atomic number is 21. Its atomic number is 30. And next goes to second transition series. It is the 4D series. It is also fifth period. It is started from the yttrium. Its atomic number is 39 and ends with the cadmium. Its atomic number is 48. And next goes to 5D series. This is the third transition series. The 5D series is belongs to sixth period. It is the sixth period. It is started from the lanthanum and ends with the mercury. Its atomic number is 57 and mercury's atomic number is 80. And next goes to fourth transition series. It is the 6D series. It is the seventh period. As per the periods, it is the seventh period. It is started from the actinium. It is atomic number is 89. It is the incomplete period. Okay. Then here in this half filled and completely filled orbitals give stability to atoms. We know that, yes. Half filled and completely filled orbitals give stability to atoms. Example, chromium and copper. Chromium and copper, these are belongs to 3D series. That means 3D series is nothing but fourth period. Here the chromium atomic number is 24. It has general outermost electron configuration is 3D 5 and 4s1 instead of 3D 4 4s2. For the stability in this, the 4s electron, for the stability here the 4s electrons enters into 3D orbital. Here for the stability the 4s, here the 4s electron is entered into 3D orbital. Why these are entering the, and I mean why these are electrons are entering from the 4s orbital to 3D orbital? Because of the energy gap. Because of the energy gap between these two sets of 3D and 4s orbital is small. That is the reason the electrons of 4s orbital is entered into 3D series. Oh my God. Okay. Okay, same similarly in case of copper, it has 3D 10 4s1 instead of 3D 9 and 4s2. In this one also here the electron of 4s orbital is entered into 3D orbital for the stability. Why these are electrons are entering from the 4s orbital to 3D orbital? Because of the energy gap between the 3D and 4s orbital is very small. That is the reason the electrons are entered from the 4s orbital to 3D orbitals. Okay, this configuration gives the stability to chromium and copper. Here, the electronic configurations of 3D series elements. The general electronic configuration of 3D series elements is 3D 1 to 10 and 4s 1 or 2 electrons. Okay, these are the elements of 3D series. These are the atomic numbers of these corresponding elements. What are the three series of elements? These are scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and zinc. Okay, these are electronic configurations of these elements. Then, how to fill the elements in their corresponding orbitals easily? Okay, then this is the trick. Okay, in this trick is very useful for your competitive purpose. Okay, you remembered these 3D series, how to fill the electrons in 3D series of elements. First of all, you will take numbers from 1 to 10. Okay, here like this: 1 2 3 4 5 6 7 8 9 10. Now doing the filling of these electrons, you don't take here the 4 and 9. Okay, then now you will take the one same as usual for the first element, and next goes to second element, you take the 2 and 3. Then next goes to you don't take fourth number, so next element, next number is 5, so you will write here 5. Here 5 is not changed because of here 5 is half filled d orbitals, yes, and 10 means full field of the d orbitals. Okay, half filled means the d orbital is having the 5 electrons. Full filled means d orbitals having 10 electrons. So no change in this 5 and 10 number. And one more thing, you don't take 4 and 9 numbers. Then next here you will write 3, and next you don't take 4. Then after the 4, then 5 will come. Then you will write here 5. Next 5 is not changed because of it is the half filled d orbitals. Next goes to you will take 6. Next same you will write 7 and 8. After that 8, don't take 9. Then after the 9, 10 will come. So you will write here 10. Now these are electrons for the filling of d orbitals. Okay, now these are electrons of the d orbitals of 3D series. Now we will fill up. Okay, scandium. Here the d orbital is 1 electron because of here 1. So you will fill 1. Next 2. Titanium, here 3D 2. Next goes to here vanadium, 3 electrons. Okay, 3D 3. Next chromium is 5, not 4. Okay, 5. So here chromium 3D is 5. Next goes to 5. Here chromium, after that manganese. Okay, manganese 3D 5. Next 6. Here manganese, after that iron 3D 6. Next goes to 7. Here cobalt 3D 7. Next goes to 8. Nickel 3D 8. Next goes to 10. Copper 3D 10, and zinc also 3D 10. Okay, the complete d orbitals filling is completed. Next go to 4s orbitals. How to fill the 4s orbitals easily? Okay, for these 4s electrons, this is the simple trick. First of all, you will write the here the inert gas elements atomic number. Okay, here what is the inert gas element? Here argon. So we'll write argon atomic number, and next goes to d orbital electrons. Okay, what are the d orbitals are electrons? What we are going to calculate the 4s electrons, then you will write their d orbital electrons. Next goes to 4s electrons. Okay, next that is equal to atomic number of corresponding element. For example, we need 4s electrons of scandium. Okay, if we need 4s electrons of scandium, then you will write here what is the atomic number of argon? 18. Okay, 18 plus how many d orbitals are present in this scandium? How many d orbitals are there? 1. Then you will write 1. Then what we are going to calculate the electrons here? 4s electrons. Okay, here 4s electrons. Okay, that is represented as x. Then equal to atomic number of that corresponding element. Okay, we are calculating the 4s electrons of the scandium. So what is the atomic number of scandium? 21. So that is equal to 21. Then that is equal to 21 minus this 19. X is equal to 21 minus 19. That is equal to 2. These two are filled in 4s electrons of scandium. Okay, I hope you understood. This is a trick. This is trick very useful for your competitive purpose. Okay, once again you will try. Then it is easily. Then you will try remaining elements. How to fill the electronic configurations. Okay, next goes to electronic configuration of 4D series of elements. Okay, the electronic configuration of 4D series elements is general electronic configuration is 4D 1 to 10 and 5s 0, 1 or 2. Okay, here also trick, don't take 3, 6, 9 while you are filling the orbitals of the 4D series of elements. You don't take 3, 6, 9. Okay, same as usual, you will take numbers from 1 to 10. Then in this, while you are writing the electrons, you don't take 4 and 3 and 6 and 9. Same as you will write 1, 2. So don't take 3. Next number is 4. So write the 4. Here the 4. Next goes to 5. 5 is unchanged. Okay. So 5. Next goes to don't take 6. So 7. After that 8 and 9 is completed. Next goes to don't take 9. So after the 9, 10 and 10 you will take. So these are d orbitals of the electrons. Now you will fill these are d orbitals of the electrons. Same as here the 5s electrons. How till these 5s electrons? Then 5s electrons is equal to the inner gas element plus atomic number and inner gas element atomic number and d orbitals present in the corresponding element and 5s electrons that equal to atomic number of corresponding element. Okay, for example yttrium. Okay, here its atomic number inert gas is inert element is here krypton. Its atomic number is 36. Next to how many d electrons are present is yttrium? Only 1. Then we'll write here 1 and plus here x means 5 electrons is equal to atomic number of this corresponding element. Yttrium atomic number equal to 39. Here the x is equal to 39 minus 37. That is equal to 2. These are 5s electrons of the yttrium. These two electrons fill in these 5s electrons. Okay. These are the 4D series of elements. These are yttrium, zirconium, niobium, molybdenum, technetium, ruthenium, rhodium, palladium, silver and cadmium. Okay. The next goes to electronic configuration of 5D series of elements. General electronic configuration 5D series of elements is 5D 1 to 10 and 6, 0 or 1 or 2. Okay. These are the 5D series of elements. These are lanthanum, hafnium, tantalum, tungsten, rhenium, osmium, iridium, platinum, gold and mercury. Same as you follow trick what you are filling the electrons of these of element, but you don't take 8 number. Okay, in place of 8 you will take 9 numbers and don't change in the 5 and 10 numbers. Okay, so these are the elements of 5D series and atomic numbers of these 5D series of elements, and these are electronic configuration of 5D series of corresponding elements. Okay. What are the transition elements? Okay. Generally, this transition element name is often used to refer to the elements of D block. Okay. The transition element name is often used to refer to the elements of D block elements. That means the D block elements is also called as transition elements. Then what is the difference between these D block elements and transition elements? And why D block elements are called transition elements? Yes, why D block elements are called transition elements? Because of the D block elements exhibit the transitional behavior between the electropositive elements are nothing but S block elements, and electronegative elements are nothing but P block elements. Okay, the D block elements means why D block elements are called transition elements? Because of the D block elements exhibit the transitional behavior between the electropositive and electronegative elements. That is the reason these are called the D block elements are called the transition elements. It is also defined as that which D block element contains the at least one unpaired D electron in its atom or ions with common, that means stable oxidation states, are called transition elements. Generally, we don't know what are these transitional behaviors. Then how to find the given elements is belongs to D block or transition elements? Yes or no? Yes. That is this is the easy for to identify the element, given elements is belongs to D block or transition elements based on this concept. That is, it is also defined as that D block element contains at least one unpaired electron in its atom or ion with common oxidation state, or called transition elements. You remember this? Okay. D block elements must have one unpaired electron in its atom or in ion state, that is the common oxidation state, are called the transition elements. Okay, the general electronic configuration of transition elements is n-1 into d 1 to 9 only, because of here the D block elements from d orbital from 1 to 9, at least one contains the unpaired of electrons. That is, so that its electron configuration is d electronic configuration of transition element is n-1 d 1 9 and ns2. Okay, in our periodic table from 3 to n, 3 group elements are transition elements. From 3 to 10 group elements are transition elements. Then how to remember easily? That means how to find easily transition elements. Okay. So first of all, typical transition elements. What are the typical transition elements? First three group elements are typical transition elements. What are the first three group elements? Those are copper, silver, arum. Copper, silver, arum means gold. These are first group elements. They are belong to first group elements in our periodic table. So these are typical transition elements. Because of here, actually the copper electronic configuration and outermost electronic configuration is 310 4s1. It belongs to 3D series. Okay, it is belongs to 3D series. Next goes silver. Its outermost electronic configuration is 4D and 5s1. It is belongs to 3D series. Okay, next go to gold. Its outermost electronic configuration is 5D10 and 6s7. It belongs to 4 series. Oh, these are different series. The copper is belongs to D series, and silver is belongs to D series, and gold belongs to D series. These are belongs to the first B group elements. Okay, okay. They have D10 electronic configuration. These are have D10 electronic configuration, but their stable oxidation states are these. Stable oxidation states are Cu+2, Ag+2, and Au+. plus 2. Means these elements lost its 2 electrons. These two, every element. That means each element lost its 2 electrons and gets the plus 2 positive charges. Okay, these are stable oxidation states. These are stable oxidation states of these corresponding elements. In their stable oxidation states, they have D9 configuration because of here Cu plus 2. Cu plus 2 is nothing but it lost 2 electrons. Okay, that is lost 2 electron from the 4s1 and from 3d 10 electron. Then it lost its electron. What happened? It gets the 3d 9 and 4s0. 3d 9 4s0 is nothing but here copper has only 3d 9 electronic configuration. 3d 9 is nothing but it contains the one unpaired electron. Yes, and that is the reason these are called the typical transition elements. What are the transition elements? What are the transition elements? Here, the d block elements at least contains the one unpaired d electron in its atom or ion with stable oxidation states. Those are called transition elements. So what happened here? These are have stable oxidation states of copper, silver and gold. So whenever it lost 2 electrons, then they get plus 2 charges. These are stable oxidation states. In their stable oxidation states, they have D9 configuration. D9 configuration is nothing but it has one unpaired of electrons. So that these are called the typical transition elements. Okay. The first group elements are typical transition elements. Note these first B group elements. The first B group elements, these are zinc, cadmium and mercury. Zinc, cadmium, mercury. These are first B group elements. Then zinc is belongs to 3D series and cadmium is belongs to 4D series and mercury is belongs to 5D series. And their atomic number, zinc atomic number is 30, cadmium atomic number is 48, mercury atomic number is 80. One more students here, 3D series is started from which element, Nana? Scandium. The 3D series started from the scandium and ends with the zinc. This is belongs first big element and 3 series. And 4 series is started from the yttrium and ends with the cadmium. And 5 series is started with the lanthanum and ends with the mercury. These are elements of each series. Okay, these belongs first B series, first B group. Okay, then these are atomic numbers of elements. And these are electronic configurations of these elements. Here, you find out are these belongs to D block or transition element. Okay, these are D block elements. These are not belongs to transition elements because of here the d orbital of these elements completely filled with the electrons. Okay, the d orbital of these elements completely with electrons. Here 310, 410 and 510. D orbitals of these two elements are completely filled. So does not have any unpaired of at least one unpaired of electron. So that these are not belongs to transition elements, but these belongs to D block elements. Okay, these belongs to D block elements, but not belongs to the transition elements because of all these D orbitals are completely filled with the electrons. That is the reason these are not belongs to transition elements, but these are belongs to D block elements. Okay, so that all the transition elements are D block elements, but all the D block elements are not transition elements. Yes, yes. Because of here already we observed here these are D block elements, but not transition elements. That means all the transition elements are D block elements, but all the D block elements are not transition elements. Here these are D block elements, but not transition elements. Because of these are their d orbitals are completely filled with the electrons in their ground states. And I will give one more example to better understood what are the transition elements in their stable oxidation states. Okay, here copper shows some intermediate behavior between the transition and non-transition elements because of they exhibit the two oxidation states. Those are +1 oxidation state and +2 oxidation state. Here, this is the general copper electronic configuration. Here 3D 10 4s 1. For the stability, here the 4s electrons is entering into 3D orbitals. Just now we studied because of the energy gap between the 4s and 3D orbitals is very small. Okay. Here the Cu plus, that means it lost one electron. Yes, it lost one electron from the 4s orbitals. Then what happened whenever it lost one electron from the 4s orbitals? Now it has 10 electrons in this d orbitals. That means this d orbital is completely filled with the electrons in this Cu plus state. Okay, then in this Cu plus 2 state, in this Cu plus 2 state, it plus 2 means it lost its 2 electrons. Whenever it lost its 2 electrons, it gets plus 2 charge. Okay, then it lost the electrons from the 4s orbital and 3d orbital. Okay, then it get the plus 2 charge. Whenever it gets the plus 2 charge and whenever it lost 2 electrons, it has one unpaired electrons in its d orbital. So from these three, which is belongs to d block and which is belongs to transition elements. Here Cu plus is not a transition metal ion because of it has completely filled d subshell. Because of it has a completely filled d subshell in its +1 oxidation state. But here Cu plus 2, in the Cu plus 2 ion, it lost 2 electrons. Whenever lost its 2 electrons, automatically it gets the plus 2 charge. Okay, in this plus 2 charge, it is a transition metal ion. It is a transition metal ion because of it has an incompletely filled d subshell. Because of it has an incompletely filled d subshell. Okay, so that the Cu plus 2 is a having the completely d subshell. So it is not a transition metal ion. It is a transition metal ion. Cu plus 2 is a transition metal ion because of it has incompletely filled d subshell. Now I hope you understood what is the difference between the I mean how to understood how to identify easily transition element and d block elements. Next goes to what are the difference between the d block elements and the transition elements. Okay, the d block elements. D block elements are with completely or incompletely filled d orbitals. Yes, just now I told you all the transition elements are belongs to d block elements, but all the d block elements are not transition elements because of the first b group elements are belongs to d block elements but not belongs to transition elements. Just now we studied. Okay, the d block elements are with completely or incompletely filled d orbitals, but the transition elements are chemically elements that have incompletely filled d orbitals at least in one stable cation. Okay, at least in one stable cation they form. Next goes to d block elements. May or may not have incompletely filled d orbitals in their cations. The transition element means they have incompletely filled d orbitals in their stable cations. These are may or may not form colorful complexes, but these transition elements forms the colorful complexes. These are exhibit the d block elements exhibit the diamagnetic, paramagnetic and ferromagnetism, but these transition elements are paramagnetics or ferromagnetic compounds. And d block elements, some are not solids at room temperature, but these transition elements all are solids at room temperatures. These are differences between the d block and transition elements. Okay, then these are test yourself questions. Silver atom has completely filled d orbitals. Okay, silver atom has completely filled d orbitals, that is 4d10 in its ground state. Okay, then how can you say that it is a transition element? Here the silver atom has completely filled d orbitals. Actually the completely filled d orbitals are not belongs to transition element. Yes, yes, but here silver atom has completely filled d orbitals in its ground state. Then how can you say that it is a transition element? Okay, the next question is, on what ground can you say that scandium, its atomic number is called 21, is a transition element, but zinc is not? Here the scandium and zinc both are belongs to 3D series of elements. Okay, here the scandium and zinc both are belongs to same series, that is 3D series. But also here the scandium is a transition element but not zinc. Okay, these are test yourself questions. Then you will write and send your answers, your corresponding and related teachers. Okay, now we are going to discuss the general and physical properties of d block elements. Those are physical properties, atomic and ionic size, ionization enthalpy, oxidation states of d block elements, and colored ions, and catalytic properties, magnetic properties, and formation of complex compounds, and formation of